So the way you can tell is when you put the screen in front, you have different behaviors that you expect from a particle or a wave, you know. And the weird thing is it displays both. It goes through one slit, makes one spot, but it also interferes with itself. And when you let enough go through, you start to see the effects of that probabilistic interference. Either all the photons that ever go through the slit are interfering, and they're still wave-alike, or it's interfering with itself. Now, if you have a respect for a concept of time that is sensible, and also for the fact that we don't see any, there's no historicity, as Professor Anton would say, in in our medium. So it doesn't know that photons went through there before. It makes sense to think that the single photon really is a wavefront. Its interaction with the screen is such that it can only create one dot here or there or various other places. But it can only create one. For some reason, it can only create one dot. We don't know why it creates the one it creates, but it does seem to be a wavefront coming at that screen and go through both and create waves. And this is all fundamentally opposed to this idea that we have entirely a wave phenomena generated by particles, that the wave phenomena takes multiple particles, for example. It's true that the wave, in a sense, is a relationship, so it has to have, extent, and it is a relationship between separate points in the field, right, of a field. Neighboring points in the field have a sort of continuity between them. Okay. So it is sort of more than one thing. It's more than one point in space. But it's not more than one particle. That one particle has a wavelength in the quantum field. And that is the wavelength that you can calculate back from the interference patterns you see if you put electron waves or photons or any kind of quantum particle through the two-slit experiment. So anyway, cheers.